All right, getting ready to mount another wheel here, but I just wanted to show you this jig. Okay, here's what I have. Let me see if I can get in there under the mill head here. Okay, I'm looking right down on the pin. Now you'll see that's a 3/8 hole tapped. That's to run that, let me see there, that bolt. Some washers on top of it. What I do is I run those down. That holds the wheel on. You probably saw that in the previous video. Now what you see here is the keyway, and there's the key. And what I do is I have this clamped in. I have the spindle. I indicated off of that diameter, which is the bore of the axle in the hole. Let me back up a second. You'll see there's a wheel, and I have the keyway cut. And there's just there's a jack right here. That just keeps it. So I drill in here just so it doesn't push down. Well, I don't think it would move it anyway. That's pretty. It's in there pretty tightly. Okay, so what I have then, I put the wheel on, and it indexes off this. And you'll say, yeah, that's it. That's weird. Well, this isn't my idea, but it was one of them I picked up on the internet. I don't know if it was Train Man or not sure where that was at. But to index the wheels, they need to be 90 degrees. One side has to lead the other by 90 degrees. So what he recommended, and has done, I think, on his Locomotive, I'm not sure, but I know that other people have, you set the keyway at 45 degrees on the wheel. So when I put this on, the crank pin will be 45 degrees off the center line of this, or off this center line between the pin, the crank pin, which will be out here, and the center of the axle, and that's 45 degrees. Now they say, why 45 and it has to be 90? Well, when you flip it one wheel to the other side, think about it, they're all done the same. When you flip that wheel around, it'll be 45 plus 45, therefore the 90. So you only have to set up one jig. And also when you cut the axles, you only have to cut the keyway in the axle. Like in the milling machine I set up, I put the axle center on the axle, and I could do both ends vertically. I didn't have to rotate it and index the spin or the axle. So that's easy, and those are in line because that's easy to set up, and this is easy. And actually, if you're running it off by a little bit, every wheel's off by the same amount. So really, that's all that matters. It's not so much the 45 degrees. It could be 46, could be 44. It's just that every wheel has to be the same. So the two on the one side will match up, whatever they are. They'll match. The diameter away from the pin will be right because I've indexed the milling machine. I have the milling head there. I have nothing in it. Right over top, if it's 1 3/4 inches over here to the center of the crank pin. So therefore, every wheel will be identical. So it'll be indexed identical from the keyway that's in the wheel, right here, to where the pin is. So if you're looking at this wheel, there's 45. So you're talking about right here, the crank pin will be about right here. And that'll be the case on every wheel. So let's go ahead and set this in there, and we'll run through a set of boring it out for the crank pin. All right, we have the wheel on. I have it bolted down. That thing's not going anywhere. So what's going to happen now is we're going to reach for our drill chock. Let's go ahead and drop the table down a little bit more. I have the pressure of taking this bit out from last time. Oh, this is, just so you can see there, this is I'm not even sure what this is called. It's still the same taper. This machine uses, let me bring these into flame. Okay, there you go. So these are the two, and this is a 40 taper, they call that. And this is a Cat 40, I believe. Same taper. The only difference is you'll see when they go up in, this one has the snout on it, the other one doesn't, but they're threaded the same. So when I go into the spindle, when I use this, I go up in here, get it right lined up. There, it's in, and then I have to drop the drawbar down a little bit further to grab that one. Here again, not an issue, just something easy. But this tooling's a bugger to find. I try to get it when I can if I see it on eBay. Of course, I have a good number of them now, so it's not a big deal. I'm gonna do a center drill. I'll just do a little bit of a center drill on this. It's gonna be a little bit loud here, but we'll deal with it. Okay, bring up the table. Gotta love the handy power feed, can't beat it. We're still in frame, I guess. That's all that matters. I don't go the whole way down. I mean, I just take a little bit, just enough to get started. Just so I know I get a straight start. Get close, don't want to race into it. I'll hold the go-go juice over here. It seems to do okay with this. You do want to keep your hand on the feed. When you're automatic feeding something, this table, of course, keeps on going whether or not the spindle decides to stop or break the bit or anything else, so you just have to watch. Chips aren't too thick, I think we're good. I'm through. I don't mind backing down with smaller diameter stuff, even if it does track just a little funny on the down. I'm not too worried about that now. Move up to a bigger drill. That was a 1/4 inch. I have a whole bunch of them around here. I always use those for starter drills. This is a 1/2 inch. I never go down long enough. I should cut one of these off or get a short length bit. You never need to drill a 1/2 inch hole that deep. Okay. Bring it up. Hit it. Notice I start and stop just to kind of break the chip. Even though I just love to just go right on through. Mess of chips. I'm not gonna mess with this thing, it'll be fine. Okay, we're through. Drop down. They're not bad at all. Shouldn't be probably doing that with my bare hands. Okay. stemming bits you could ever buy. I mean, I have no idea where I even got them from. I've had them forever. They're garbage. I really need to get a good, either just get a new set of them or what. They're junk. I just can't seem to talk myself into buying them. The good ones are expensive. So I always just make sure I don't use them for anything that's critical. I'm through. Okay. This time I'm smart. Take the bit out first. What I'm doing up top, you can't see it, but I'm just tightening up the drawbar. Snug it up. Okay, snug. Bring up the table. Have I ever crashed out doing that? Yes. That's why I get plenty of space now. Okay, here we go. Might be a little fast for 11/16. I don't know. But I'm not taking much. There's not much of a chip load there. It's a 5/8 pull, so a little over probably knowing how chunky those bits are. See the ring pop off the bottom. Stop. Withdraw. Yeah, not too bad. I got a little bit of a mark on there. Like I said, it does make a mark when it comes out. There's just nothing I can do about it. And this machine's old, the ways are shot. That's life. What are you gonna do? Okay, drop it down. Never quite give it enough room. There we go. And that's it. We got to end up with a nice, I mean, honestly, yeah, it has a little bit of a mark on it, but I mean, that's nothing. I mean, it's perfectly smooth, beautiful hole. It's going to clean up nice. Like I said, all I'm going to do, I'll measure it. I'll create a plug, put that in there, light press fit. We're going to be done. Maybe you'll see that part too. Okay, there you go. Thanks for watching. What the heck, let's run through another series. Oh, I gotta make a new handle. I hate that one. It's so short. Can't get any leverage. Alright, here we go. Not sure what the status of this metal is. It's plate. It was hot roll plate. I don't even remember where I got it from. Oh yeah, I did get it from. Oh, I know where I got it. It was inch plate. I got it flame cut. Oh, yeah. It wasn't bad. I got it well oversized. Got through all the flame cutting. That wasn't a problem. I have the other video where I show turning the wheel, put the flange on it. I said, I think this is the way to go. Especially when there's so much meat around the hub. I don't know, I'll have to show you. You'll see later in the plan. It's not like there's any crack that's going to be created by the keyway. I know that's something that, I don't know if that was what was in the prototype or what. I know they always point it towards point the keyway, you know, towards the crank, and because it is thicker right there. That's a thick, you know, when they had the wheels that are made with, you know, the spoked wheels. So it does make sense that those would have been, the keyway would have been towards the, you know, towards the crank pin, which would have been the thickest part of the wheel from the hub to the crank pin. So that makes sense. In this case, these wheels are disc wheels that only have 2 lightning holes that are going to go right here. The rest of the wheel is solid because it's supposed to be a little switcher that goes, you know, European style. So that's why I'm not getting excited about it. I think it's, I mean, same with the size of the keyway. I mean, I have a Minuteman broach set. That's the size of the slug that fits in there and follows the broach. Is 3/4, it's an 1/8 inch key. I mean, something might look a little light. In all actuality, the axle even looks a little light. I would think that it probably could have been, you know, heavier. Maybe it should have been closer. Maybe it should have been a 7/8 hub. Maybe 15/16. You always want to have it turned down though if you're using an inch axle. You want to turn it down so you can actually get a good fit. So that part makes sense. But yeah, so I think it's going to be I think it's going to work. I'm talking. My wife just popped in. So okay, let's see, what do we do here? We're switching over. This is the last one. Bring this up. It's the last reel. I didn't even know I was making a YouTube video. I was looking for the cameras right here by the mill. I have a tendency to talk to myself all the time anyway. So it's not like it's surprising she would walk in and listen to my conversation with myself for a period of time before I would see that she was walking in. So there you go. So maybe have the camera here. Maybe I should just not even have it turned on. They wouldn't even know it then. They would assume I'm always making YouTube videos. A little noisy. So like I said, these bits are junk. Total junk. Okay, we're through. Okay, let's pull that out of there. Oh, we can start putting tools away. This is going to be good. We'll clean this machine up. And on to the next step. Just putting those lightning holes. That's going to be a fun video. That's actually going to be done. I'm hoping to use a hole saw. I don't know if it's going to work. I'm going to try it slow feed. real slow. Lowest speed I can get and lowest speed I can get. And just take all night and run through, because I'll tell you what, I really don't want to sit and bore a hole. It's a 2-inch hole I'm shooting for. I really don't want to just sit around all night drilling, starting at a 1/4-inch hole and opening that up. Lighting on that. Not too bad. Can't believe that camera lens hasn't been sprayed yet. What's thing you do with the Chinese plant, put them in the vise, run an end mill across the end of that, flatten it out. They're never flat. They always have that they always have the taper from the, there we go, from the foundry taper on the face. I don't know why they can't finish that, but that's always a problem. Okay, well there it is. Another set. Maybe I'll show taking it off. Yeah, let's do that. Pop that out. Get this out of my way. Okay, what I do is I loosen this up. Take those off, set that over here, put the bolt back in a couple turns. I have 2 clamps. I'll loosen up the one clamp. This takes 3 hands. 3 sets of hands. Probably should make a wheel puller. That'd be a good little project. Out here. Actually had something like a long time ago. Remember it had a beam on it, like an inch, piece of inch stock beam. Look at this. Just turns it, pops that right off. Then I just kind of hold it up, put my hand over there, grab that other clamp, and to wiggle it. I mean, still, there we go. Come out. Not that it matters. Okay. Take it over to the bench and clean it up. Okay, we'll drill a hole in a wheel. Pick it up mid the operation here. That is a 5/8. I'll check here in a minute as soon as it goes through. I'm running about 520 RPM, a little hot. 2 inches per minute on the feed. We're through. Dropouts. Let's take a look at what we got here. Okay, great. Now we're gonna switch. Final hole. I don't have reamers here. You know, it's just classic. Don't have them. So what I'm going to do, I just switch over. To an end mill. Punched it out pretty close. As you can see, it's not going to that bad of a deal. Put that in. Bar here. Homemade wrench. Has both ends. I can see this end for tightening the nut above. This end is for taking the collets out of this Cat 40 taper adapter to R8. Wait, what is that? R8 collet adapter. So we got that in there. So there's our wrench. Plop that down. Okay, let's bring it up. Bring it up a little closer. Let's see where we end up. There it is. Okay. Grab a little bit of go-go juice. Let's hit it. See what we get. I want to take a little bit out of that hole. I don't have a reamer and I want to finish a nice hole. If you go and drill, you don't know what you're going to get. It's a mixed bag. So I just always finish off with an end mill. I don't know, it seems to work pretty well. Keep some lube on it. We should be pretty good here. Go through. Hey, they might not be accurate, but they'll be consistent. That's what I'm after. I want a consistent hole. I'm going to make the pins, so I'll drill the holes first, and then I'll make the pins to fit the hole. I mean, that's just easier. I'm going to take a piece of 3/4 and turn it down. That's 11/16, I believe. There it is, top to bottom. Shut her down. Here again, this might not be acceptable, but I do it this way because this table has some play in it. I'd rather drag it out. Even if it puts a few marks on it, that's okay. If I run it out, it's going to open up the hole because the table has play in it. So ideally, it would probably be to drop the collet out, move it down the table. I mean, what are you going to do? There you go. One hole, done. We will come back and show setting up the second hole. Okay, here we go. We're going in with the end mill. We're on another wheel here. Just thought I'd show that again. I don't know why, but it's kind of cool. Just using the end mill as a drill or a reamer. Not saying it's the best way to do it. And obviously the hole's probably going to be larger, somewhat larger than what the end mill said it is. The end mill's 11/16. Is it going to be a little bit larger? Probably, because any runout you have is going to show up in there. Is it better than the drill? Of course. It's a 4-fluid. The drill's a 2-fluid, so any of the triangle pattern that the 2-fluid drill was creating hole, the 4-fluid should clean that out. So that's why I think it's the right way to go. Especially if you don't have a nice set of reamers, which I have adjustable reamers, but I don't have really nice chucking reamers. So there you go. So just withdraw lightly. It doesn't leave much of a mark. I'm not going to get excited about that. So it's only, I'll look at them closer when I get them out of here. But yeah, I think we should be good. Okay, there it is. One more to go. Hey, poor man's wheel puller. Was using something. Hey, maybe someone never thought of this or not, but these wheels go on here and they're stuck on there's a stub that comes out of the 3/4 stub with a keyway, and of course once you drive the keyway and everything's a little tight, you can't pull it off, and I don't want to mess with the jig or wrestle with it, but I don't have a wheel puller that goes over the 7 inches that this wheel is plus the flange. So just take a piece of 3/8 by inch bar stock, lay it across there, grab 2 C-clamps, and there's a bolt in here. Actually, the bolt that I use to tighten this down, I just back it out and just start tightening the C-clamps. So actually just get the one close, tighten the other one down, it leverages it right off, pulls it right off. So there you go, poor man's wheel puller. Alright, I'm out here in the shop. Figured I'd maybe get a little bit of video of this. Boring some 2-inch holes in these drivers. I've been working on these for a while. You probably saw them in other videos. These are holes to lighten up the crank side of it. So it's a 2-inch hole cutter. I actually went through one of them, burned up this bad boy here, Even had to weld it, knock some teeth off it, learn a little bit more about how to use these. Went out and bought a little bit better one here. It's Milwaukee, and it has a little heavier, the arbor that it's on, it's a little heavier. So went ahead and using this. I'm running it at 400 RPM, seems to be the best, surprisingly, and ½ inch per minute feed. That's the way this machine feeds. It doesn't do a clutch feeds per revolution in 1,000. So you get, obviously you calculate that out. So let's go ahead and keep on board and see what happens. Just under power feed. I just keep it doused with some, this is my sprayer I use for my cooling. It's thickness of the wheel is about an 1/8 inch plate, machined down to 813 thousandths. Pretty decent. Keep the fluid to it. Cleans the chips out pretty well too, that's what I like. I don't have to keep backing out, which would be a real pain on this machine because you don't use the spindle, you're using the table. It's hot though. There we go, we broke through. I like to wait for the plug to drop out the bottom. There, plug dropped out. Okay, so what we're gonna do now, we'll drop down, give ourselves a little room. I don't know if that stayed in focus actually, pretty well. Just like to get away some of that stuff. I've already done, not terribly hot. Look at that, not bad at all. Yeah, so the cooling's working. Okay, so what we're doing now, finish off the hole. You don't get the perfect hole with that. Pull that out. I have a boring head here preset. I've been doing the other holes with it. It's been working out real well. Snug that up. Bring it up here. Okay, close enough. Found this works real good at 300 or 298 as it says on the on the K&T here. Okay, so we'll go ahead and give her some go-go juice here, moving ahead by hand. Okay, we're close. Hit the power feed. And go ahead and clean her out. This gives it a nice finish. This hole saw actually held it a little tighter to 2 inches. than the previous. So I actually have this bore on this to about 2 1/16. It's actually just a decorative hole, so it doesn't matter, but I want it to look smooth inside. So that's why I just finish it off with the boring head. Here's a, I hope you can hear me on these, but there's a plug that knocks out. Hey, that saves a lot of chips. You can take them out. So I got 1, 2, 3, 4, 5, 6 plugs already. So 6 plugs. I got 8 to do total. 4 wheels, 2 holes. So there it is. Go ahead and follow it through. I'll go ahead and just probably fast forward to the end here. It got speed, it works real well. I'm getting some chip build up, but it's real soft. I mean, it's soft chips, not a big deal. It'll come right off, but I don't get any of the chatter. 400 was a little too fast for it. My feed's the same, I just leave it at 1/2 inch per minute. That boring, let me show you that cutter. Well, that's going right here is what I was using. This really helps a lot. These areas here, it lets the chips from the inside come out through, and it's held up pretty well. I mean, it's feeling a little duller than it was, but I haven't knocked any heat off. Like I said, I only got 2 more to go. Boy, if it can just get me through 2 more here, I will be happy. Yeah, so I'm hoping, I don't know, I'm going to give it a shot. Hopefully it doesn't give me trouble. Sharpening these, I'm not sure. I don't know if I take a Dremel to each one of these teeth. If I could take a Dremel to the inside, maybe even a hand file. I don't know, it's a bimetal saw, so I mean, you should be able to do something with it. This thing's got a shorter shank, I guess you don't see. Let me move the camera a bit. There, how's that? That's better. She's swinging. We're almost through though, so it's not a big deal. Works out real well. I've got a support over here. I think I've shown this before, and I had to put these behind here to stop the chatter. Really seemed to help out with the wheel. Okay, we're through. Let's drop it down here. Yeah, we did all right. Okay, good deal. Thanks for watching. Okay, just started another hole here. I think my bolt cutter's been going a little smaller on me. I'm taking more off of this one than I had before. It's odd. I don't know. I'm not sure what's going on. But I had to drop the speed down a little bit. So yeah, I don't know.